Good afternoon, everyone. So today we will continue working on Unit B, Matter and Chemical Changes, and we will have some reinforcement on what Mr. Ali did previously. So I just want to highlight what are the outcomes that we will be focusing on today from the program of study. So basically we will be using the periodic table and we will do some predictions. So the agenda.
You have low battery, 10%.
Serious?
Should be okay though.
Okay. Continue?
Yeah, sure.
Okay. So today's agenda for this class is to differentiate between elements and compounds. Again, we will recap on this aspect and identify the elements and their position in the periodic table and identify the subparticles in an atom. Okay, so we will start by a quick activity very similar to what Mr. Ali did, just to recap and reinforce the concept. So we will be working, or you will be working in pairs. And the instructions are on the screen. So you will build any shape you'd like to have. Read, you have two definitions in the back. And then determine which definition would better suit your building. Okay? We have 2 minutes to finish that activity.
No, jeez.
They got sweet ones.
We need a pure stuff.
We used to do these things where one person would draw a line, and then you pass it back to the next person, and then you would have to draw like 15 lines, and then you'd have like a giant strip.
Okay, 1 minute left.
Enough story. What twist it? What's in the story?
Yeah, best thing ever.
Oh, what is it? So, which one's
I think it's good.
So I'm pretty sure that.
Oh, I mean, like, you're supposed to hear about it. This is supposed to
Okay, if you think your shape represents a compound, come and stand by the front left. If you think your building represents an element, come and stand to the right. Come. So if it is a compound, to the left. If it is an element, to the right.
Oh yeah. Are you sure? Not so else.
So within your group, justify your choice and give me a working definition for either element or a compound. Okay, you have 30 seconds to discuss within your group.
This is a compound because
It's
it's
all
made
the
up
same.
of two or more.
Yeah.
Well, they're all the same thing.
Different things. Yep.
Okay, so let's start by the first group. What do you think?
It's an element.
It's an element. Why?
It's only one thing. It's all the same.
They are all same. They are built. They're being built from the same unit. Okay. What about the second group?
compound.
Why?
This is being built with a lot of different elements.
A lot of different elements. Okay, good justification. You can go back and sit in your places.
It's okay. Just
Okay, so as you said, the element, and as Mr. Ali previously mentioned, the element is a substance composed of a single particle, right? And as a compound, you can see here that they are made up of, in this particular example, of two different elements chemically bonded together. When I say chemically bonded together, I mean they are stuck together. So when they are chemically bonded, they are stuck. If they are just scattered like this, this might represent or a mixture, right? But if they are chemically combined together, they are stuck together, they will form a compound. Okay. Going back to the previous picture, what is the difference between these two representations? So we are having element, we are having something called molecule, and we are having compound, right? Can anyone tell me the difference between these three terms?
An element would be like one of these, and then the molecule is like all of these together.
Yes. So you said the element is made up of, maybe we can say an atom, one type, right?
Can't be broken down.
Cannot be broken down. Brilliant. And what about compound? Two or more, and we said what? Chemically combined. What about the molecule? Can you tell me the difference between this or this and this? What is the difference? You said that this is element, right? And you said that this is an element, right? What is the difference?
One is red.
One is red and one is yellow. Okay, another difference.
There's 2 and 1.
There is 2 and 1. Very good. So when you have 2 atoms joined together of the same type, they are a molecule of an element. When you have 2 molecules joined together, but they are different, they will represent a molecule of a compound. Make sense? Any questions? Okay. Okay. So we define the element, we define the compound, and here's the mixture. As we said and represented by the blocks, they are scattered and they are not stuck together in case of the Lego. They are separated from each other. So now it's your turn to tell me, what is this? Is it an element, compound, or mixture?
Mixture.
Mixture. Can you identify a mixture of, apparently we're having 2 kinds here, right? So it's a mixture of 2 elements or 2 compound or
2 elements.
2 elements. So the green represents one element, the red represents another one. Very good. What about this one? Is it an element, compound, or a mixture?
Compound.
Compound. Why?
Because there's 2 elements joined together.
They
Chemically.
are chemically joined together. You have 2 different elements joined together, chemically joined together. That's why it's a compound. What about this one?
Mixture.
A mixture of 2 elements, 2 compounds, 1 element and a compound. What do you think?
1 and 1.
Elements and compounds.
Elements and compound. These purple dots represent an element, and these 2 represent a compound. Why is a compound? Because we have 2 different elements chemically joined together. Make sense? Okay. So, this is the periodic table, and Dmitry Mendeleev was the one creating the periodic table. I know that in grade 9, this is your first time to be exposed to the periodic table and elements. So before doing any work, you will tell me what is a periodic table. So, what is the next activity? You will be given each pair think, ink, pair, and share. What is this? It's a kind of graphic organizer where you individually think about the questions that I will give you. You can open your textbook, you can refer to the periodic table, or you can go for a quick search. Then, with your pair, you will figure out and discuss and give each other feedback on why you did so. And after the pair, you will join as a group and finalize your answers. You can go back to the think, ink, pair, and share to adjust any of your answers if you felt like doing so. Make sense? Clear instructions? Okay. For the sake of time, we're going to do it. So these are the instructions for you to follow. So, as you knew from the activity that you just did, the periodic table is a kind of arrangement of the elements that we have. And here, we will have interactive periodic table. There you go. So, what can you identify from the periodic table? What can you see? What are these? What are these?
Symbols.
Symbols of
Elements.
elements, okay. And basically we are having groups. So these are the vertical lines, we call them groups. And the horizontal lines, we call them periods, right? Okay. So, how can we classify elements? How can we classify elements? So, think of all the elements that you know and what you practice in the think, ink, pair, and share. So, what kind of elements do we have?
Metals,
Metals, yes. Can you give me an example? Like
iron,
yes, perfect. And what else?
Non-metals. Non-metals.
Non-metals, excellent. Like what? Can you give me an example?
Oxygen.
Oxygen. Okay. So in here, you have the link in the PowerPoint that will be on your Google Docs, so you can play with the periodic table. So for example here, I can check the metals. So all of these elements are metals. And here what we call it the zigzag line. And we call them, they are neither metals nor non-metals, we call them metalloids. And we have another section in the science course, we will know more about the characteristics of metals, non-metals, and metalloids. If I want to look for the non-metals, these are the non-metals in the periodic table. So again, all of these are metals. Zigzag line, there are metalloids, and after the zigzag line, we're having non-metals. Again, we can classify elements according to temperature, okay? So you have here the indicator. So these are solid, liquid, gas, and some unknown atoms, because as you know, science is evolving, and sometimes we're having a theory and we can change that theory later on based on evidence. So the nature of science is evolving, it's not fixed. So as a scientist, we need to have this in mind. So these are different ways we can classify elements. Okay. If we want to focus on one particular element in the periodic table, I'm having this particular example, which is carbon. If I want to identify the different components in that box, what can I see here? I can see a letter, I can see a name, and I can see two numbers, right? What does this mean? Any thoughts? So, this element is called
Carbon.
carbon, and the symbol is C. And I want to drag your attention to a very important point. Most of the elements of the periodic table, they are even given one letter or two letters, right? If it is one letter, it should be capital. It should be uppercase. Like what? You can look at the periodic table.
Carbon.
Carbon. Hydrogen. What else?
Boron.
Boron.
Sulfur.
Sulfur. Okay. If the symbol of that element is made up of two letters, what is the rule here? What is the rule?
First one is capital.
The first letter should be capital and the second one
Lowercase.
small or lowercase. Can you give me any example of elements with two letters?
Aluminum.
Aluminum,
Sodium.
sodium.
Xenon.
Okay, and we are having here two numbers, right? Some periodic tables are different from others. They are not all identicals. So you can see carbon 612 in some periodic tables, and in others you can see carbon or C 12 and 6. Any rule here? Which is which? Before dealing, I will let you think about this question and come back because I need to explain what the atom is made up of. Okay. You can still think about this question. Okay. So the atom is made up of three subparticles. So we are having something called protons, neutrons, and electrons. What are these? These are tiny little particles inside the atom. So the protons, they are positive. Neutrons, they are neutral. Electrons are negative. Even though the atom itself has some charges, it is electrically neutral. Can anyone tell me why or how it can be electrically neutral, even though we're having some positive charges and some negative charges? Think about how can anything be neutral, having charges within. Yes, please.
They have the same amount of protons and electrons.
Brilliant. So when the number of positive equals the number of negative, they will be neutral. So because the atom is electrically neutral, the number of protons should be equal to the number of electrons. Yes. And in here, you don't have to know the shells in the atoms at this stage. However, looking at this diagram will just facilitate the understanding of the topic. So in here, the center of the atom, which we call it nucleus, we can see positive charges. What do we call positive charges? What do we call positive charges? Protons. And what do we call the neutral?
Neutrons.
Neutrons. So in the center of the atom, we are having, I can't hear you, protons and neutrons. What is left?
Electrons.
Electrons. So these electrons will be revolving around in certain shells. Make sense? Okay. So, I said here we have two numbers. So one is atomic number and one is the mass number. Okay? So the atomic number is smaller than the mass number. Okay? Atomic number is the number of protons or the number of electrons, because we said they are equal because the atom is electrically neutral. And the atomic mass or the atomic weight is the number of protons plus the number of neutrons. So you can see here, it's always the atomic number smaller than the atomic weight. So even if I have carbon 12 and 6, I can say that 6 is the atomic number and 12 is the atomic weight. It doesn't matter where to put these two numbers. Okay, so knowing this fact, you will work in group and you will create your own atom using 10 beads. Okay, create your own. Okay. Okay, we have 2 minutes to finish that activity.
We can do this.
Remix.
No.
So it's like what?
Shotgun a couple.
That's for easy.
I have another
That's
one.
easy.
I guess so.
It?
Holy. Okay.
That'll be easy.
Dunk.
So you.
3 minutes.
No, you don't.
Okay. So once we are done now with creating our atom, everyone will be given a set of cards. You will stand up. You will have some clues on these cards and decide which element is this and post it under the correct element. Ready to go? Okay, you can stand like and figure out which element is this and put it under the correct name.
Oh, we have lunch.
Yeah, periodic table for this, right?
Yes, you can use your periodic table for sure.
I think we're looking for that's 5 protons against a nucleus.
Oh, sorry.
All good.
Oh yeah, we are having some hidden elements in here.
Oh, sorry.
Oh, there.
Okay. You can use the glue if you want to stick your responses. So here you have some glues.
That's good.
Brilliant, yeah.
That's right. Do you have more? It's only like about 30 seconds left.
Okay, so it's time to recap. Back to places. Thank you. So now it's just time to recap on what we did. So we focus on what are elements, or what is an element, what is a compound, And what is the difference between atomic number and atomic weight? So again, you will have this PowerPoint as a kind of summary to what we did today. And see you next class.